Picking up again. So we left off here with the get ops, and then we're going to cover arrays and kind of revisit some of the functions again here. So get ops is very confusing at first glance here, but I think we'll walk through it and understand it. So here kind of we have the syntax of it all, and I'm kind of explaining it some down here. So that op string is a list of valid, and this is important, single letter options. So the get ops is going to allow us to parse options to a customized script that we create. One of the downsides to it is we can't do like any type of long version. So like, an actual word as an option. So it's going to force us to use just those single letters. And I'll apologize, I'm losing my voice today. So hopefully I can make it through this. And then we got the var name. So that's a variable that receives the options one at a time. So this one's going to be all of our options in there. And then we have some special stuff like op index and op targ. We'll see a list of those and kind of explain them. But understand that by itself, GetOps really doesn't do that much. We have to actually integrate it within a while loop and a case statement. So two things we've previously learned. Now we're going to integrate all three of these together to be able to kind of create a loop that loops through all of the options before the actual program is being run. So opt-in, that's just an option index. Opt-arg, this is a little bit confusing. It stores the option related value, so the arguments that belong to an option. So think of the tar command. And then what do? We want to create, we do the verbose, and we do this -f right here, and then we give some type of file name. So this is a perfect example. This is the argument, right? This would be the argument to the option right here, F. So that'd be the file name. So that's all that is doing is optarg will be a variable in the background that just holds that information that you type as that argument to the option. Then we'll come back to well, no, we'll just hit them one at a time. So notice you got the colon here, and you got the colon here. They all have completely different meanings. Linux is wonderful that way. So if you put it after an option, it just indicates the option takes an argument right here. So again, that -f, that would be a good use case for that. The colon before all the options mean we're going to turn off the default error messages and we're going to create our own. So it kind of has just some built-in generic options, but if you put it before all the options, it's going to turn all of that off. Then we got these cases. And so this is, you can think of the case statement. This is exactly what it is right here. Very, very similar in the fact that star is kind of the catch-all. It's the default. So if they give an option that isn't in a list, what do you want your program to do? And then we have some more specific ones if we really want to narrow it down. So if somebody, if you give it a list of, okay, your valid options are C, V, and F, and then someone gives it an S right here, then you could create a custom error message, or you could branch your script to do something completely different if they were to give an invalid option in that case. Then you got the colon here. So it specifies the action to take when GetOps detects a missing option argument. So again, that -f right here. So if they just put -f and didn't give the argument here, then you could create a custom error message for that occurrence. We'll actually open this up and kind of go through it and line by line here in a second. Just a few things I'm going to point out that it does. You can see the -u option. So that's where that gets placed in right there. So if that is run, then we're going to run this code section right here. So it's going to change everything from lower to upper. If we do the C, then this option right here is going to get run, and that's just going to take all of the blank spaces and then replace them with a colon that's in that string. And then if you did a -f right here, then that is basically creating a log file. So all the changes that we do in here, instead of it just printing to standard out, it will still print in this case, but it's also going to save it to a file. And again, we'll walk through it. And then pointing out a couple of other things here. You can see I'm using some of those special cases right here. -h is just common as a help message. And just because I didn't want to make this so long right here, instead of doing the asterisk, I'm just trying to show you that you could do this right here, and it's kind of our catch-all. But we could have we could have just done this with star. So if anything actually occurs, that's wrong. And then we could display a message right here, but it's however you want to do it. And then of course we're using those ors in the case statement. So each one of these right here takes place, then it's going to trigger this error message. And like always, again, I don't have that error redirection. I haven't updated all of my code in here for that. Let's see. Yeah, I think that's enough. So let's take a look at this. There we go. So let's film. Okay, so in this program, all we've got is a string right here that has a welcome message, and then we're declaring another variable. Of course, it has no value whatsoever. Here we have our get ops. We put that inside the while. So every time that the while loop triggers, it's going to trigger get ops for us. So it kind of creates this loop that's going to loop through. And then of course, the length of the loop is however many arguments are being actually supplied to the while loop. So here is all of our valid ones. The fact that we put that colon at the beginning, that means we're going to handle our own error messages. And then because the colon comes after the F, that means F is unique in those options. We actually have to give it some type of argument to that option there. And then each option is actually going to be stored in the variable called option here. And then, so while we're in the while loop, we call a case statement. And then, so if we type in U on the screen here or on the, when we run the script, it would be assigned to option. So the variable option would have U, and then it's going to pass that to the case statement right there. And then the case statement's going to do its normal thing. It's going to look and see if there is a U. Of course, there is. Then it's going to trigger, the actual command here. So in this case, you can see that I did just an echo. So here's the string that we have. It already has a value. So here I'm declaring that same string again, and then I'm echoing out its contents and then sending it to TR. And then of course it's going to take all the lowercase and change it to uppercase and then overwrite itself. So it can do that because we're simply echoing it here, and it's going to do all of its stuff and then send it back to string. So it's just overwriting. Now, what's this one doing right here? Yeah, good deal. So if I had a file instead of a string right here, what would I need to put right here as the redirection operator? Just a single one. Perfect. We're catching on. So same thing, just two different methods right here. I like this one. As you see, it's a lot kind of less code right there. And then we have save file. So if F gets run, we have the empty variable right here. And all I'm doing is remember that option argument that's in the background. So if we do -F, and then we give it an argument. So like in this case, it'd be a file name, then optarg is just going to automatically hold that value in the background. So what I'm doing is I'm just, extracting that. So whatever name we give it, and I'm adding .log to it. And then that's going to be saved to the actual file name. And of course we have our catch all right here. And I believe, I hated that I did those recordings right there. Have we covered base name? Anybody remember it? I think it's in a chart somewhere on there, but I don't think we've really covered it in detail. Base name. So if you have a full path, so like /home/J Corcoran, and then this script right here, base name will strip off everything and leave you nothing but with the script name. So it allows you just to strip a path off super easy. There's other methods of doing it, but base name is just kind of a quick way of doing it. So what I'm doing right here is if there is a path, I'm just removing that path, and $0 will be the script name. Or you could do it like this right here, which just doesn't strip the path. So these are the same thing. I'm just showing you two different methods. You could throw in the base name to remove that path. And of course, we have the end of our actual statement or case statement. And then here, this is pretty cool. I'm doing a -N. So that is just checking to see if save file actually has a length to it. If it does, then I know it exists, it has a value. And so if it has a value, then I want to trigger this. And then the fact that the string right here, so whatever value it has, I'm going to redirect it into a file, which is save file, that variable. So whatever name I give to the actual script, it'll save that as a file with an extension of .log at the end. And then in here, we're just echoing out the content. So, you know, whatever we done to it, we can actually see it right there. Else it's just going to echo the string. So if we didn't decide to save right here, none of this gets triggered and just the string itself is displayed. So let's show this. So if we do /getops.sh, and if I hit enter here, you can see it just defaulted. There was no changes. So it just gives us the welcome message. Now, if we go in, we actually give it some options. I believe the first one was U for uppercase. You can see now, put everything in uppercase. If I did C, it's going to change all of the spaces to the colons there. And then we could also combine them. It doesn't even matter what order we combine them in. Now you can see it did uppercase and the colons. And then if we did -F right here, you can see that it had the colon in the code right there, meaning it needs an actual argument supplied to the option. So that triggered our usage statement. And so we need to actually give it, we'll just do test right here. And now you can see it went ahead and did this different message right here in saying that this was actually saved to test.log. So we can cat out test.log and see that that was also saved right there. So what you got?
What if you have one, like let's say U gets rid of all the spaces, but then C does something like replace the spaces, which one would go first?
It would be it's looping through. So just think of it that way. So if you called one that maybe changed everything to uppercase, and then you called another option that changed everything to lowercase, whichever option you put first would basically lose the fight in that case. Any other? Good question. That was a great question. All right. That's pretty much it on that. So any questions before we move on? All right.
Is that script available anywhere?
Well, I mean, it's not like as a download, but it will be in the slides in there, right there. So yeah, exact same code right there, only it doesn't have like the double usage statement. This one just has the base name as it should be. And I didn't really show y'all that on there, did I? The two different ones. See, I was running this one in the actual same directory here. So it did the // right here, but the base name stripped that off. And so if I would have ran it like, you know, from somewhere other place and it had the home/J Corcoran, it would have all that path on there too. For instance, make myself clear on that. So if we did / lecture 10 and then did the getops.sh, hit enter. Oops. I need an invalid option to F. Then you can see it's going to tag that on there too, lecture 10. So it's just a way to strip it all off there. All right, moving on to arrays here. There are kind of two different types in here. We have the index and the associative. So this one out here, obviously, it's just using numbers. Here, you can kind of create anything you want. You can put strings, whatever you want as the key value. So here, the keys are index or integers, positive integers. Here, it can be anything. There are some limitations. One of the things is, well, actually, I guess it's not a limitation, but you can do multiple data types. You don't have to worry about that, but they are not multi-dimensional arrays whatsoever. So just single dimension. They do not support array elements inside the array. And then they're all untyped, as you can actually do multiple data types, but there is also no limit to how much you can actually store in there. So here's how we declare them. Now this is going to get a little confusing because there's obviously, or just like multiple things in Linux, there's so many different ways to do it. So this is going to be the indexed arrays. So we could do this. We could explicitly declare using the declare keyword and then passing the -A option to it for the array, and then create the actual name right there. And then we could go through and reference our array name. And then, of course, this index would be a positive integer starting at 0. So you could create 0 right there and set it equal to some value and just keep on repeating that. And then you would have your array. Of course, that's a lot of typing. So I would suggest doing it down here where it starts the same. Then you reference the array name, but instead of giving it a value right afterwards, you do the parentheses right there. And then you just put each element in there. Notice that there is no delimiter. The delimiters are white space. So you just space it out. You can, just like pretty much, I think every scenario that I know of when you're using parentheses, they can touch right here. You don't have to have white space. You can, I mean, it's up to you on what you want to do there. Again, if you just have a rule of thumb of putting white space on brackets and parentheses, it always works. So it's kind of easier to remember that way instead of remembering which one does. And of course, this one, you don't have to actually specify those. They are just auto numbered. So you would just have 0, 1, and 2 that is automatically created for you. When it comes to associative arrays, so unlike over here, we could just have the array and it would default to an indexed array. But if you are creating an associative array, you have to use the declare -a, capital A, sorry, to be able to create the associative array. Otherwise, it's just going to default to that indexed array. So same method here. You have the array name, and then in the brackets, you can put anything you want. It could be text, it could be numbers, it could be anything. It really doesn't care. And then you give it your value. You can shorthand it the same method here, but still you, because it is an associative array, there is no type of auto indexing that can take place. So if you use the parentheses, you still have to do the brackets. You just kind of start each entry with a bracket right there and give it some type of string value as your key. All right, so if we're wanting to reference, we're wanting to actually get the values that are in there. You can see right here, I created an indexed array right here, and we have these values. So we got 0, 1, 2, and then 3. And then if I want to actually reference a single element out of there, I can do echo. And I told you we're going to see that bracket syntax a lot here. So when it comes to an array, you have to put the kind of the variable name here inside the curly braces right there. So, and then you have the bracket and you just give it the number. And of course, that would be helium right here. So you get the output. This right here is something I drew from a question one time in class. I just left it in there for reference. So you can easily see, the arrays, of course, how they're indexed. Of course, you can reference the from the n as well. So this is the length of it -1 because it starts at a 0. So that would be your very, very last one right there. And then you can reference even these with negative numbers. So if you did -1, then it would get you the very, very last. -2 would get you here, there. Okay, so this is just examples again of showing you explicitly declaring them. And then right here, I'm showing you example of not explicitly declaring. You can simply just kind of like you create a variable. The way it knows is the fact that you kind of put these parentheses after there, or if you did a bracket in that case right there, it would work. But again, with the associative array, you have to actually use that declare -a in order for that to work right here. So this is index only that it works right there. And of course, here we're just explicitly giving it the key value of 0 here and setting that equal to foo. But again, I really, really like using the declare word, especially then declare -a. So that way it's easy to see here that I am declaring an actual array and not some variable in there. And it gets that nice color code as well. Okay, so printing, if we want to print all of the variables, we've talked about how @ and star work right here. Same rules apply to that. So if I just want to get everything of that variable, I would just not do like an indexed number or a string there. I can just simply put the @ and it's going to echo out all the values that are in that string. Now, both of these cases right here, because there is no quotes around, it would simply do a list. Now, what would happen if I ran let's just do this. What would happen if I ran this right here? Somebody tell me, would it be a list or single string as the result? It would be a list. Perfect. All right. Now, what happens if I put this right here? What would be the result? String. All right. So the same rules apply to that. So if you put double quotes around it, it changes their meaning. So at does a list, star does a string. If I was to erase this right here, then both of them is actually producing a list right here because there is no double quotes around them. We can actually show that theory right there. Didn't check what was the name, array, at, and star. So if we did dot slash, oops. We'll do at first. And then in there, so we'll just cat out that so you can actually see the code is a little bit different. So I just created an array with some names in it right there. And then I'm for looping through the array. And so since we did at right there, at is a list. So it's going to have all of those arguments separated as, you know, different arguments. So it's going to echo out each one, and each one it's on its own line there. Versus if we did slash array star. And then in here, you can see that it's just going to do a single string right there. So not multiple items there. And then of course, if we want to just see at same exact code right there, only I did a star. And of course, they're in the double quote, which changes that option. So you can see I have that echo. So it did not loop through it all the different times there. It was just one single echo statement. Okay, if you want to actually get the keys, if you actually want to see what the keys are, then you can, within that curly braces right here, you can precede it with an exclamation point. And so don't get that confused with the not, because it is not a not, it is the key in this case right here. So you can see that we have 0, 1, and 2. So we only want the keys right here because we're doing the at symbol. And of course, you know, the for loop's going to get it the value here, and then we're echoing that out. So we get the 0, 1, and 2. And the same thing with here, we have an associative array where these are key, foo and baz, and then we echo out the actual keys and we just get foo. There, we should get that right there, foo and baz, not foo and bar. Now, luckily, again, they actually stuck with something. You know, Linux doesn't like to do that very often, but when it comes to the length, they actually did the pound, and they actually did it within the braces, and they even did it preceding the variable name. So they really stuck to the pattern there. That was nice. So you can see right here, we have 3 elements in that array. And then we created this string right here, the array contains, and then we list our variable. We give it the at, so it has access to everything in there. It's just going to spit it out. Of course, it's in a list format, so it did count those as 3 elements. Okay, when it comes to adding, what you got?
All right, on that last slide, can you ever reference an array without using the brackets for the index, like just using the array name?
Not to get its values. You won't. You have to do the brackets every time. Good question. So when it comes to adding, there's 2 different methods right here. So you can see in this one, we have an indexed array and we just reference the actual index, so 0. So whether if it has a value or not, if it has a value, then we're overwriting it. If, you know, it didn't have a value, then we're adding it to it. But you can also see where we can do this plus equal. So we have an array declared already, and we do plus equal the baz. And then if we were to echo it out, you can see it just tags it on to the end. The same way with you want to do multiple ones separated with a space. Also know in this example, how I didn't do space right there is completely valid. If you put space before or don't do it, it all works. See this one, what's the difference here? Oh yeah, this is just showing you using the associative array. So here we've declared it, and no, sorry, we declared it, added a value here. Yeah, and then we're just adding to it right here. So same thing, you just have to actually specify that key within the brackets. There's no auto indexing that's taking place. When it comes to deleting elements from here, so we have our array, and then if we were to use the unset keyword here on the array and then reference an index, then it's just going to delete that right out of the index. Now, pay special attention what it actually does here, because you can see we did 1, so we have 0, 1, and 2. It just knocks that off, and then when I echoed it out here, you can see the index is 0 and 2. It doesn't auto update or anything. It just 1 and no longer exists, so 0 and 2 are left.
What if we do additions to the array? Is it always at the end, or if there's like an open spot like that, would it add it later?
It would add it to the end. It would every time. Because it is an append function. And I think that's a better word. I should probably replace it. It's not really adding, it's appending. All right, so now if you want to clear the contents of the array, there is a kind of a special way to do that. Or actually, there's 2 different methods of doing it. So you can see here, we're creating the array, echoing out its contents. And then in this one, I'm just resetting the array. I'm just setting the value to nothing. So it's overriding all the values. The fact that I used the same syntax as I used up here on this line, it's just I gave it no values. So then it clears the entire value. The array still exists right here. And then we also have the unset. So let me show you a brief example of that. So we just did array and set it equal, hang on, where dash a array, set it equal to, we'll just do A, B, and C. And then if we were to echo out, let me see if I can get all the syntax right, array and that. So a lot of typing just to do that. So here we get the contents of it. Now, if I wanted to actually overwrite that, I could say array equals and hit enter here. And then if we were to do declare dash A, you can see here's our array. It still exists, has no value. But if I was to go over here and say unset array, hit enter, go back, declare dash array. Now you can see that array no longer exists. So there is a difference. You know, if you just clear it, the array still exists. It's still in memory. It's just, it has no values. So here's pretty much everything we've talked about into a nice little list for your reference right there. The one thing that we didn't talk about is, you remember the string splicing that we did? You can actually do that with an array. You're just listing the elements right there. And so understand that this is the index of the array, and this is kind of a count afterwards. Let's actually just go back to that. Jacob, Ted, Steve, Bob, Amy. That should be enough right there. And then if we were going to reference it, and we just, of course, we can do that, reference it first. Then I could say, okay, start at index 2 here. So you can see Steve and Bob. Then I could say, okay, from there, I want to go 2 more spaces. So then include Steve and Bob only. And if I was to say just do 1, then we've narrowed it down to just Steve there. So you can splice those up if you want to. All right, any questions on the arrays? Fun and exciting stuff, right? All right, so reviewing bash functions, just a little bit in some more detail here. Of course, this is kind of just the list that we've been building on throughout the semester as a reminder. So in this example, we're going to talk about more about passing those arguments. We've done that a little bit. We've not really talked about it a whole lot. So here I've just, I have a script that I'm writing. Of course, there's the shebang. And then here's the actual function. Again, you don't have to do this. It's kind of like a Google best practice is to put an underscore on functions just so it shows there in your code. It's easy to see this is a function, but you won't be graded on something like that. And then here I'm saying echo $1 and then welcome to the $2 class. So those are what type of variables are those? Can somebody tell me? Positional parameters. So we have special and positional, not such a big deal, you know that, but that's what they're called. And then of course, in the screen and in the script, it is required that you actually call it. Some people that mixes them up. They create the function, they don't ever call it and it never runs. And so I'm passing in these 2 arguments here. So that is mapped simply to here, $1 and then $2. And so if we actually run the script, you would just get hello, Joe, and welcome to the Linux class. Now, make sure you remember that because we're going to come back to it. Now, this is some of the odd stuff about functions. They are quite limited in Bash, but they get the job done for the most part. They really only return the success or failure. So 0 for success, or 1 through 255. You have this keyword, which you can kind of control what return or what number is returned right here. So you could say return 55. Of course, I run this function, and then it's going to actually give me right here, I'm echoing out the status. So I'm calling the function and then immediately echoing the status, and then it returned the status of that function. Of course, that one would mean that technically it failed in that case. But again, there's nothing that's going to trigger the script to actually quit there. So using it that way, I don't ever use return on it. I think that there are much better ways to handle it. They've come up with workarounds for that. The first workaround is the fact that since a function runs in the same shell as the script or the shell that spawns it, it has access to all the variables there. So you could think of it by default, everything is global to a function because it has access to it. So you could simply just overwrite a function that you've declared in your script. And then when you can reference that same variable within the function, you could override it. So if my var was declared outside of this and it said Jacob, I could simply overwrite that, and then it would be overwritten in my script right there. Now, that is one way of doing it. I don't totally like that. I actually like this result right here. But again, this one right here is pointing out one, I declared a variable called myvar equals hello. Then we have the local variable right here. When we run the function, you can see that everything, when we run the function, there is no echo. So there is nothing to standard out. The function just runs, and then nothing is really displayed. But when I echo out my var and my var2, you can see that the my var2, because it was local, it has no value because it's just local to that function. But this one right here, my var hello, will actually get executed. So you kind of got to be aware of that scope and understand that if you can have the same variable names in your function as you do in your script, it's kind of not a good best practice to do that. But as long as you create the local keyword before it, then it's okay. It won't bother those other variables you created in your script. Now, when you're wanting to actually get like all of the output from your script or from the function, and you want to save it, this is the way that I like to do it. You simply create a variable, use command substitution, and then call your function within the command substitution. And in this case, the only thing it's going to return, it would send echo to standard out, but echo is not going to go to standard out. It's going to be captured by the variable. And then you can choose later when you actually want to display or use that value that was returned in your script there. And we'll cover printf a little bit later, so don't get confused on that one. All right, so again, this has been at the end of every one of my slides. I want to remind you all of that because in some of your homework that you got returned, we did have the issue of this right here. I didn't count off much for it whatsoever. Matter of fact, the whole entire assignment was 50 points. The rest of these are 100 points, so it was worth half. And again, not much knocked off, but I do want that header at the top of it so I can easily see who it is. Sometimes I just extract these things and they're auto graded through a script, so I like to be able to see who's there. And then, of course, comments. I want you to explain your comments. And I don't want something just at the top that says what the script does. That does not explain your code. I want something that is explaining your code. Of course, in that assignment, there wasn't much to explain, but it will get kind of deeper and deeper as we go on. And of course, your exit codes and then your return or your redirection right there. This was missed probably more than anything on that homework assignment was the exit 0. So just make sure wherever your script is going to exit for success, you go ahead and put in that exit 0 there. So this right here, again, I'm not going to say this in the assignments every single time. This is just, you are expected to do this every single time. Of course, we have the script maker in there that you can add a lot of this stuff in there. So every time you create a script, then it will automatically have the reminders for you to do that in it. We covered that in class. I think it's even downloaded on this one and the previous one. It'll be that scriptmaker.txt. Okay. Now let's take a look at some things here. Share.